Hello everyone, and welcome to Sadiq Maths 6-7. Now we're going to go through an exam paper that we took last week, and I'm just going to go through the answers very quickly. I'm going to explain some of the concepts in more details in other videos. Now let's look at the first question. It says choose a correct word from the choices below that best fits into the sentence. Now the first one says how far a typical data value is from the mean. Now we've looked at absolute value. Absolute value is the distance from zero. Now absolute deviation is the distance from the mean. And how far is same as saying is asking for the distance. So for example, if I said how far is England from Saudi, what is the distance from Saudi to England or England to Saudi? It's the same thing. So that would mean it's mean absolute deviation. And we could just say MAD for short. So MAD stands for mean absolute deviation. Now the second question says a distribution of data values on a number line is called. So the answer for this one would be box and whisker plot, aka also known as a box plot. It's like those Minecraft cats with that are square with the whisker. So I've only drawn one whisker on the either side, but cats usually have whiskers, not mustaches. Yep. So think of it as a Minecraft cat with whiskers. Now, so this one is box. I could just call it box plot. Absolutely fine if you put that as the answer. Now, the third question is the difference between the third quartile and the first quartile. The first quarter of the data and the third quarter. And that's what we call interquartile range. So imagine we have Q1, we've got Q3, and Q1, first quartile is 3, third quartile is 10. We're just looking at the distance from the third quarter. So the distance, which is the range, from the first quarter to the third quarter of the data. First quartile to the third quartile. How would we find the distance from 3 to 10? You would minus the numbers from each other. So Q3 minus Q1 to 10 minus 3, which is 7. That's just an example. Again, I'll show you this in more detail in other videos. So the answer here is interquartile range, but you could just put IQR for short. Now, number 4, data that is divided into 4 equal parts. If something is split into 4s, they're split into quarters. And quartiles. So that will be the answer. We call it quartiles when we're splitting data into 4s. Quartiles. Please don't write Q for short. Just write the whole word. Number 5, a graph that uses bars to show the number of values in each interval category. Now, if we have a graph and we have the bars that are rectangular, I know some people drew, at the end of the paper, they drew a histogram, and they drew some very imaginative shapes that I've never seen in my life before. Looks more like Tetris. Anyway, so it's going to be bars that are going to be together. So I'm just drawing an example, histogram. They're all going to be together, and we'll explain that more in our last question. So the answer for this is histogram. And the key to that is intervals, and we're going to find out what an interval is later on. So we've finished the first part of our paper, section A. Okay, let's move on to section B. It says circle the correct answer for each question. So a frequency table shows now how data changes over time. It can't be this answer because we're looking at totally different categories. Red, green. We're not looking at how red changes to green or green changes to blue. Definitely not this one. So let's put a cross on that. The exact middle of the data. Nothing's telling me where the middle of the data is. I'd have to calculate that myself. So it won't be this one either. The shape of the box plot. It's not giving me any indication of the square cat with the whiskers. Yep, no indication of any cat here. So let's cross that off. And it can only be B, which is how often each value appears. How many reds do we have? How often does it appear? 5 times. Green, how often does it appear? 6 times. Blue, 2 times, and so on. So that's pretty straightforward. Now let's look at question 2 in section B. It says the prices of video games are shown below. Which measure best shows the typical price? Now, typical, I know a few students got confused about this because typical can mean common in everyday English. So choosing mode, the mode is 30, is not a silly answer. But in statistics, typical usually means a good representation for the whole data set. So what number are we going to choose to represent all of the numbers I have here? Now, if we were to choose the mode and we were to choose 30, it's kind of skewed to this side. It's not giving me a good representation of all of the numbers I have here because I've got 70, 60, 55, 40, 30, 30, 30. Okay. Median is the middle value. Yeah, it's in the middle. But then we've got the mean, which is 45. 45 is closer to 70 and it's closer to 30 than 40. And plus, we do not have any extreme outliers, so the mean is the right answer. Range doesn't even come into it. So we would either be choosing the mean, median, or mode. Usually, it's a choice between a median and the mean. If we have no extreme outliers, we choose the mean. If we have an outlier, we choose a median because the median is not affected by outliers. And I know a few students in the exam asked me, Sir, what is an outlier? I can't tell you because it was an exam. So you just have to go and study and retake the test again. Okay, so let's move on to our other questions. So we've got question 3. A data set has a minimum of 4, which is the smallest number in a data set, and a maximum of 19. What is the range? I had someone ask me, what is the range? How do I find the range? Again, revise. Please don't ask me those questions unless you want me to do the exam for you. Now, to find the range, which is, so for example, if we have 4 here, let me just put the pen on. We have 4 and we've got 19. We're looking at a distance from 4 to 19. How would I find that? I'd find a difference. So I could say 19 minus 4, which is 15. Some people put 14. Please just be sure of your answer before you put it down, because that's a really silly mistake to make. If you need to, count on your fingers, count on your hands, count on your toes if you need to. So the answer is 15. It's usually the highest value minus the highest value minus the lowest value. Okay, let's go on to question 4. A nutritionist is tracking the sugar content grams of 5 brands of cereal. What is the mean absolute deviation of this data set? The data set is as follows. Now, I understand a few people put 18, which is understandable, and I'm going to come to that in a second. So we're looking at mean absolute deviation. The mean is usually the sum of all of the data points divided by how many there are, which is 5. So we're adding all of these together. So when we add it together, what do we get? Okay, so the answer is 90 over 5. Now let's do 90 over 5. Let's do it up here. So we have space. So how many 5s go into 9? 1. 5 times 1 is 5. 9 minus 5 is 4. Bring the 0 down. 5 into 40. We have 8 as 8. Goes 8 times. So the answer, the mean is 18. Now we found the mean. We're not asked to find the mean. We're asked to find the mean absolute deviation. So as we said before, absolute deviation is the distance from the mean. So how far is each value from the mean? So we've got our mean as 18. So we're going to take the absolute value, absolute deviation. So 8 minus 12. So 18. Sorry, 18 minus 12, which is 6. 18 minus 15, which is 3. 18 minus 18, which is 0. 18 minus 20, which is negative 2, but we're only interested in positive values because we're taking the absolute deviation of it. So it's just 2. We're only interested in positive numbers. We're interested in the distance from the mean. Distances really can't be negative. And 18 minus 25 equals negative 7, but because it's the absolute deviation is 7. Now we've got our distances from the mean. So the next thing we do is find the mean of those differences, of those distances. So we have 6 plus 3 plus 0 plus 2 plus 7 divided by 5. So this can be written as 18 over 5. Now, if you left it as a fraction in a normal exam, it would be absolutely fine, but we've got to choose one of these. And then they're decimals. So I would convert it to a mixed number. How many 5s go into 18? 3. Remainder 3, and the denominator stays the same. Now we know 3/5, or you should know 3/5 is 0.6. Because you're splitting 1 into 5 parts. 3 of those parts will be, one part will be 0.2. So 0.2 plus 0.2 plus 0.2 is 0.6. So we end up with 3.6, which is our answer. Now let's go on to the next two questions. Question 5 says, what is the outlier of this data set? Now an outlier is an extreme value. It's either very, very, extremely just means very, very, very large, big, different from the rest of the data values, or extremely small, very, very small. Extremely means very, very. It's extremely cold. It's extremely cold weather, or we have extremely cold weather. We have very, very cold weather. What is different? Spot the difference. Now, I think, which is obvious. It's not I think, I know. that 20 is very far from the other data values. So the answer is A. Sorry, number 6. So number 6 says the following data set shows the number of minutes students spent on homework. We've got our data set here. It's already in order. What is the interquartile range of this data set? So we're looking at distance from the first quarter to the third quarter, first quartile to the third quartile. Now, in order to do this, the first thing we do is find the median. What's the median of this data set? It's just the middle number. As I can see, the middle number is 25. Now, once we find the median, then we just find the median of either side of the median that we've already took. So we find the median of this side of the data and the median of this side. What's the middle number here? 30. What's the middle number here? 20. So that means that this is Q1 and this is Q3. That's all we're interested in, to find an interquartile range. So 30 minus 20 is 10. So the answer is C. In case we had, so for example, 4 numbers on either side, say we had another number 90 here, we would choose the 2 numbers in the middle and add them together and then divide by 2. Okay, so let's move on. Now it says, which value is the upper quartile in a box plot? Is it the smallest value? Sorry, let me just do this. Is it the smallest value? Is it the middle of the upper half? Is it the middle of the lower half? Is it the largest value? Now, guys, if you just looked at the paper closely, you would have seen that we've got Q3 here. And if you didn't see it, it's not a problem, but you should have already known it. That Q3 is the third quarter of the data. I don't even need to see Q3 to answer this question, so we know it's B. It's section C, question 1. Now it says, Soviet's question, a school hosts a fundraising dinner yearly, builds a frequency chart for the number of tickets sold each year. Complete the histogram. Now it's telling you clearly, stating clearly, I want you to draw a histogram. Now, if you were paying attention in class, which you should have been paying attention in class, you would have heard me repeat that when you're drawing a histogram, there should be no gaps in between the bars. On a histogram, the bars are in the shape of a rectangle. They're not in the shape of Tetris shapes, because I saw something that looks like someone played a lot of Tetris. No, and I also saw some drawings that I've never seen before in my life, but I'm always learning something new, right? So we know it's a histogram because it's got one category, just tickets sold. And the reason why we use a histogram is that when there are too many different numbers, we just group them into intervals, into ranges, to make the data easier to understand. And therefore we've got the number of tickets sold, and we have the frequency, which would be the number of years. So what that means is that there was 1 year where they sold 45 to 54 tickets. There was a year, there were 0 years where they sold between 55 to 64 tickets. There were 2 years when they sold between 65 and 74 tickets, and so on. So here we've got the intervals of number of tickets sold, So 45 to 54 tickets, there was 1 year. So we're going to go to 1, go across, go down. 55 to 64, there were no years where they sold. There were 0 years when they sold between 55 and 64 tickets. So we're going to leave that blank. There were 2 years when they sold 65 to 74 tickets. So we're going to go up to 2, go across, go down. So remember that it's in the shape of rectangles. The bars are in the shape of rectangles. Now 75 to 84 goes up to 5. Go across, go down, and it's joined together because it's continuous data and it's one category, as opposed to a normal bar chart. So, for example, if we had different categories like cats, dogs, birds, the bar charts won't be joined together because they're different categories. So let's just finish this off. 85 to 94, there were 12 years. So we're just going to go up to 12, go across, go down. And last one is 4. So that literally took me a minute to draw the histogram. I know some people are spending 20 minutes on it. That just means that you do not understand what you're doing. It's not that you need extra time, because even if I gave you 5 hours, you probably wouldn't do this. Now, that's why it's important to revise or understand what the content is. Again, if you have any questions, please come to me and ask me, whether it's by email or in person. Absolutely fine. Now, let's move on to our last question. Now it says 7 students competed in a puzzle competition to see how many puzzles they could solve in 10 minutes. The number of puzzles solved by each student is listed below. Create a box plot on the number line to visualize the results. So even if you don't understand anything that you just read or I just read, we know that the data set is this. Are these numbers here? This is not the data set. This is just a number line. Please don't confuse the data set with the number line. So we've got our data set. The first thing we're going to do is find the median, because what we're interested in is 5 values: the minimum, the maximum, Q1, Q3, and the median. And that's why they call it a 5-number summary. And the summary means a short version of the important information. So we're just looking for the important information. We've got a data set, we're looking for the important information, and those 5 things are the main points. So the first thing we're going to do is find the median. It's the middle number. The middle number, as I can see, is 8. Then, as I said before, we're going to find the median on either side of the median we just found. So what's the middle number? What's the middle number here? 10. What's the middle number here? 7. So this is Q1. This is Q3. This is the median. This is the median. And this is the smallest number in the data set is the minimum. Biggest number in the data set is the maximum. Now, I've got our 3 numbers. Five numbers for our summary. Now, all we do, draw 5 lines over each number. So we've got the minimum, which is 6. So let's draw a line there. I've got 7, so I draw a line there. Got 8, draw a line there. Got a 10, draw a line there. And 11. So now I'm going to want a box in the middle. So I just draw a box, and then I draw a line to the maximum and the minimum, and that's it. We've got our box plot. That's all you had to do. Again, people were spending 20 minutes on it, which means you don't understand what you were supposed to do. So hopefully now you understand. Next exam should only take you 10 to 15 minutes. Although I don't give you 10 to 15 minutes, I give you nearly an hour, but it should only take you that amount of time. If you have any questions, please let me know, and please revise. And next exam, don't ask me questions like what is an outlier, what is the range, because I'm not going to tell you. Thank you very much. Thank you for watching the video, and be sure to subscribe for more videos. Thank you very much, and goodbye.